Hey everybody, welcome back to Newegg TV. I'm Steve, and today we're going to do an overview and look at some benchmarks for this PNY 480GB SSD drive. That's PNY's XLR8 Pro model. So here's a look at the box itself. This is of course PNY's XLR8 Pro 480GB size. They also come in 120GB and 240GB flavors. This is the SATA 3 revision 3 model, which is the 6 gigabit per second interface. Of course, I'm going to flip that around and show you a little bit of the features on the back here of this actual drive. It is 2.5-inch SATA 3, as I mentioned before. The controller is a Sandforce 2281 chip. Then of course we have the MLC NAND inside. It is 2-bit per cell, and this particular drive has on-the-fly encryption. The performance, it's rated according to PNY to have sequential reads of up to 550 megabytes per second and sequential writes of up to 515. Random read IOPS, we're looking at 85,000 read and 85,000 write. Of course, there is also a 1,200,000 mean time before failure, and that bleeds up to, they're giving it a 5-year warranty essentially. Let's take a look at the actual device itself. Pull that out for you. They do give you a SATA 3 cable that would be backwards compatible for SATA 2 as well, if you need that. And inside we have the actual drive itself. Take a look at it. It is a metal case, and if I flip it around, you can see the actual model number itself and the drive size, which I've already noted. You can take a look here at the actual connectors. The SATA power and the SATA 3 connector goes here. Okay, I do want to mention too that this particular drive is 9.5 millimeters thick, so if you needed to use this in something that would need to have something thinner, like an Ultrabook or something like that, you might want to look at a different PNY drive for that particular solution. So you'll notice here I've also peeled back the sticker here to remove the screw. That also, of course, voids my warranty. If you don't want to void your warranty, just stick to this video and you can find out what's inside without having to do any of that. Here's a little bit of the thermal tape that's on the back of the chip that was actually stuck to the top of the case here. And here's the actual PCB for the SSD. Let's move that out of the way. You can see here the Sandforce 2281 controller. This particular controller is capable of transferring information to up to 8 channels, hence we do have 8 NAND chips here. That controller is also really close to the SATA 6 port here, obviously by design. So as you can see, there's more NAND on the other side, another 8 more chips of it. This particular NAND is synchronous mode IMFT NAND, and it is MLC, or multi-level celled, and that also means that it's going to have 2 bits per cell. It's rated for 3,000 program erase cycles, and I actually want to show you how well it did in our benchmarks. And here's our benchmarking setup. We're starting out on an Intel Core i5-3570K. That's running on Asus's Maximus 5 Gene Z77 motherboard. Of course, we're using the native SATA 6 port on that. So let me just show you our first benchmark. We're using AS SSD, and there we can see megabytes per second on the left and IOPS on the right. First up, the sequential read and writes. We're looking at 514 megabytes per second, writes at 322. Looking at the 4K performance, we're starting at 25 almost megabytes per second and 20 megabytes per second on the right. 4K 64 thread, we're seeing 213 megabytes per second on the read and 110 on the write. Access times really low when you compare it to a mechanical hard drive. We're looking at 0.1 milliseconds on the read and almost 0.2 on the write. Looking at the right here, we'll see all the IOPS scores, and we'll see the 4K 64-bit thread seeing or 64 thread, excuse me, 54,700 IOPS on the read and 28,200 on the write. Total score for this is 601. Go ahead and go to the next one. Here we'll notice the synthetic benchmarks for ISO, program, and gaming. From top to bottom, we see a speed of 378 megabytes per second under a duration of 2.8 seconds. Program, we're looking at 213 megabytes per second. That took it 6.6 seconds to complete. The gaming was 244 megabytes per second and 5.65 seconds. And moving right along, we're looking at the compression benchmark on AS SSD. In this particular case, this drive does incorporate on-the-fly compression. So you'll notice at the beginning where nothing is compressed, we're looking at a dip of as low as 153 megabytes per second, jumps right up to 300-ish, and then rides the climb all the way up to 100% compression, where we see a total of 480 megabytes per second and 517 megabytes per second. Moving right along to the next benchmark. Well, this is Atto, and this is what the manufacturers like to use. We did it in two different QDIPs, QDIP 4 and QDIP 10, but first we'll look at the 4, which is also going to be more than most home users are going to see. We see it top out here on the right at 521,000, and we're looking at a read of 551 megabytes per second. So that is a speed of 521 megabytes per second on the right and 557 megabytes per second on read. If I go to QDIP 10, we're looking at a maximum here of right around 520 megabytes per second write, and a read of, it looks like, 556 megabytes per second. I'll move to our next benchmark. This one's from Blackmagic Design. This is their disk speed test. Of course, Blackmagic Design deals primarily with video, but if you wanted to see how your particular drive would perform using their hardware, their uses, you can see on the chart here we have all of the different resolutions and all the different color depths. Anywhere it's a green check mark, they're saying it's recommended for that. Anywhere there's not, they're saying they don't recommend this drive for that particular use. The write speeds, we're looking at 327 megabytes per second, and read at 519 megabytes per second. Moving to Crystal Disk Mark, this particular benchmark is also using compressed data. We'll look at the IOPS here, and the sequential read and write megabytes per second here. You'll notice it is reaching 514 megabytes per second on the sequential read and write of 509 megabytes per second. Looking at 4K performance, you're looking at 36 megabytes per second and 28 megabytes per second for the read and write. If you look at a 4K QDEP of 32, you're jumping up to 226 megabytes per second and a write of 194. If I move to the left here and look at the actual input-output per second, we can see the 55,000 IOPS, translating to random read 4K at QDEP 32, and then we see 47,000 IOPS for the random write at 4K QDEP 32. And moving to the uncompressed data, we're seeing actually a bit of an increase there. Sequential reads are 525 megabytes per second, and sequential writes 317. Jumping to 4K performance, we're seeing 32 megabytes per second read and 20 megabytes per second write. If I jump across to the IOPS, we're looking at a maximum here of 55,430 IOPS at random reads of 4K and random write of 22,400. And that concludes our benchmarking and overview of this PNY XLR8 Pro SSD drive. It is 480 gigabyte capacity. If you like this video, go ahead and click the like button. If you haven't already done so, click subscribe, and we'll definitely see you soon.